The title of 7.1 is Picture This. The goal is to get us to start visualizing how we write equations. Starting with number 1 on page 342, it says, there are two main sections in a small town called the hill section and the lake section. The town has a population of 3,496 people. The number of people who live in the hill section is 295 more than twice the number of people who live in the lake section. How many people live in each section of the town? One method to solve this type of problem is to draw a picture that models the situation. In the picture, you can draw a rectangle or box to represent an unknown quantity. So for part A, it says, in the given situation, one unknown quantity is the number of people living in the lake section. Draw a box to represent this quantity and label it with a P. So for now, we're just doing as the book tells us, and we're drawing one box with a P in it to represent the population of the people that live in the lake section. Part B says, next, draw 3 boxes to represent the people who live in the hill section. Label the boxes P, P, and 295. So our first box is P, second box is also P, and then we have a third box that we're labeling with 295. B then asks, why do you think these boxes are labeled this way? Think about why the boxes might have these labels. Use the picture to calculate how many people live in each section. Well, if the total of all of these was 3,496, we then need to figure out how we can find the number of people living in the lake section. We can look at our picture and see that we need to take off 295 to get closer to just one single piece. So we can take 3,496 and subtract the 295. That would give us 3,201. Then we still have 3 P's left. We have these 3 boxes, and we got rid of that. So now we need to divide the 3,201 by 3. And then we get a total of each box with a P in it is equal to 1,067. So that gives us the answer for how many people live in the lake section is 1,067, because that's what the value of 1 P is. Now to find the hill section, we need to add together 2 P's. So I can add 1,067 plus another 1,067 because there's 2 boxes with a P in them. When I add those together, I get 2,134. And then I also need to look back, and here we had 295. So now I also need to add in the 295. And I should get a total of 2,429. This is the amount of people that live in the hill section. When I add those together, I get 3,496, which is again the total population. The next page says you can represent the picture you drew as a mathematical sentence using operations and an equal sign. An equation is a mathematical sentence you create by placing an equal sign between 2 expressions. We know what equations are. We deal with equations all the time. And here they're saying that this is an example of an equation because it has an equal sign. One way to write an equation is to think about writing it with words. One equation you can write for the population in a small town situation is the number of people in the lake section plus the number of people in the hill section equals the 3,496 total people. Now that you have written the situation in words, let's think about how to write it in an equation. Part D says, first, write an expression to represent the number of people in the lake section. Let P represent the number of people in the lake section. So all we need to write for D is a P. E says, write the expression to represent the number of people in the hill section. Notice this little guy down here says, 295 more than twice of a number. So we can represent twice of P, or 2P, and then we also want 295 more than that. So we have twice P and 295 more, or 295 more than twice of P. Finally, write an equation to represent the total number of people in the small town. All we're going to do then is, like we did previously with the pictures, is we're going to add the lake section plus the hill section. So we have P, and we're adding that to the 2P plus the 295, and we know from the story problem that that is equal to the 3,496. So that is our equation. Again, equation just sets two things equal to each other, and here is our equal sign. So we have the lake population plus the hill population equals the total population. You are going to move on to page 344 and try number 2 on your own. So you have 2A through D on your own. We will check it in class, and when you're ready to move on, when you have it all completed, you need to move on to page 348 for section 7.2. So go ahead and try number 2, and when you're done, press play. So we are now on 7.2, which is page 348 in your book. Problem 1 says each representation shows a balance. What will balance one rectangle in each problem? Adjustments can be made in each pan as long as the balance is maintained. You need to describe your strategy. So what they're saying is these need to stay equal to each other. So whatever you do to one side of the balance, you also have to do to the other side of the balance to keep them equal. So if we choose to subtract off 6 squares from the left-hand side, then I'm also going to subtract off 6 squares from the right-hand side. I'm left with 9 little squares and 3 rectangles. Again, my goal is to find out what each rectangle is worth. So I can start splitting up these little squares, and I'm going to put 3 in the top rectangle. I'm going to put 3 in the middle rectangle, and I'm going to put 3 in the bottom rectangle. This shows me that each rectangle is worth 3 squares. So my strategy was to subtract 6 from both sides and then divide the 9 squares into the 3 rectangles. Go ahead and try parts B and C on your own. When you're ready, you can press play to check those answers, and then I'm also going to have you try number 2 on page 349. So try B, C, and number 2, and then when you're ready, you can press play. Here are your answers for part B and C. You need to subtract off 3 squares from both sides. Remember, whatever you do to the left, you have to do to the right. And then you can also subtract off 2 rectangles. And then you can see over here we are left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares and 3 rectangles. So we need to break the 12 rectangles up into the 12 squares up into the 3 rectangles. So 12 divided by 3 will give you an answer of 4 squares is what 1 rectangle is equal to. Same thing on this side, we need to subtract off some stuff. Here we can cancel out 2 little squares on both sides. and we can subtract off one rectangle from both sides. And then all you have left is 3 squares are equal to 1 rectangle. You should have also tried part 2. If you have not tried part 2 yet, you need to make sure you pause the video and try it on your own first. But basically all part 2 talks about is the fact that when dealing with equations, you need to treat both sides equally, and whatever you do to one side, you have to do to the other. So when you go through part A and D, you see that when you subtract a quantity from one side, you must do the same thing to the other side. Alright, I am now on page 350 in your book. Number 1 says, rewrite problem 1, question 1, part A, using variables and numbers. So we're just going back a couple pages to question 1A, and in that question you can see the scale, and it wants you to represent the rectangles with an X and just the little squares with the numbers 1. So in part A, we had 3 big rectangles, which would be 3x, and then we also had 6 little squares. So I have 3x plus 6, and sorry, that kind of looks like a multiplication sign. 3x plus 6 was set equal to 15 little squares. So when we write our equation, we have 3x plus 6 equals 15, and now we need to determine what balances x, or the rectangle. And we do just what we did in the picture example with the scales. We subtract 6 off from both sides, and you're left with 3x equals 9. And then we also had to divide the last boxes into the rectangles. So we're going to divide both sides by the 3 rectangles that were left. So if we had 3x equals 9, we divide both sides by 3, and we're left with x equals 3. And again, x represents the rectangle, so each rectangle is worth 3 little squares. Part B says to substitute the value of x back into the original equation. Does the value of x maintain balance in the original equation? Make sure you show your work. So we're going back to our original equation, which was 3x plus 6 equals 15, and we're going to substitute in the x that we found with the value of 3. So now instead of an x, I have a 3, and I just need to go through and solve. Remember your order of operations. You may have learned it way back when as please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction. So in this case, when we're multiplying these out, we need to take care of our order of operations, and we need to do the parentheses first. So this 3 gets distributed into the 3, which means multiply. So 3 times 3 is 9, plus 6 equals 15. Now we can handle any addition. So 9 plus 6 is 15 equals 15, and that is true. It checks off. C says you just solved a two-step equation. Describe the order of operations you used in the original equation. So this, you can go ahead and describe what we use with your please excuse my dear Aunt Sally, or the order that you had to work through in. So you can answer part C. And then part D in your book says compare the way you solve the equation to the order of operations in the original equation. So when we worked up here in the original equation, first we subtracted 6, and then we had to divide. So they're going in opposite orders. This time we worked through orders of operations from the top to the bottom. And then in the original equation up here, we had to work backwards through our order of operations and do any subtraction and addition first, and then do any multiplication or division. So answer part C and D on your own, and then when you're ready, I'm going to move on to page 351. So when you're ready, press play. All right, this is the last example I'm going to do for you tonight, and then I'm going to let you off onto your own. Before number 2, it says, when you undo operations, it is often simpler to undo them in the reverse order of the order of operations. Or in other words, the operation that comes last in the original equation should be undone first. So again, we had the please excuse my dear Aunt Sally, which was the parentheses, exponents, multiplication, division, addition, subtraction. Normally, you're going to work through from top to bottom. But when we're trying to undo the operations, we start down here. We start down here with subtraction and addition first. So I always like to box these off and say we do these first and we do these second. We can kind of ignore these. We don't use these much when doing these types of problems. Number 2 says, write a sentence to describe how to apply inverse operations to solve each equation. Then solve each equation and verify your solution. So first, we're going to do the same thing that we did. We have to take care of any addition or subtraction first. Okay, again, our goal is to solve for the variable. So we're looking to get x all alone on one side. So we need to get rid of everything else. How do we get rid of a negative 15? Well, then we add 15. Oops. If we do it to the left side, we also have to do it to the right-hand side. So we're adding 15 to both sides. Here they're going to cancel out. Negative 15 plus 15 is 0, and that's what we wanted. We're looking towards the goal of getting x all alone. And now we're one step closer to that. Next is to take care of any multiplication or division. That's our second step. So here, our variable x is being multiplied by 4. When they're right next door, it just means multiplication. Opposite of multiply by 4 is divide by 4. If I do it to the left, I have to do it to the right. Anything divided by itself is going to cancel out and give you 1. So we just have 1x left over. And then 76 divided by 4 gives us 19. The problem also wants us to go through and verify. So we're going to plug 19 in for x into the original equation. So we have 4 times 19 minus 15 equals 61, and again I kind of messed that up. 4 times 19 is 76. 76 minus 15 is 61 equals 61, and that checks off. So go ahead and remember to work backwards through your order of operations. Do any addition or subtraction first, and then go through and undo your multiplication or division. Try parts B, C, and D. When you're done, I'll have the answers for you, so you can press play. And then after page 351, I want you to finish all of page 352. So you need to do B, C, and D and check them with the video. And then we will check page 352 in class tomorrow. Okay? You do not have to do talk the talk, so just get through page 352 and then check your answers to A, B, C, and D. Here are your answers to A, B, C, or sorry, just B, C, and D. B is equal to 2, C should equal 22, and then D should equal either 9 over 2 or 4.5. If you did not get these answers, you need to check at the work I did. Make sure that you worked backwards through your order of operations. So always start with canceling out your addition and subtraction first, and your multiplication and division second. Oops, that should have been a first. Okay, so if you did not get the correct answers, rework through them and try again. Otherwise, make sure that you ask questions in class, and then you need to finish all of page 352. Oopsies. Oh, I don't know what I'm doing there. All right, then you are done for the night. Have a good one.